Hi, Assalamualaikum. Today we want to present about a group project which is Fourier transform application in RSC circuit. First of all, we would like to introduce ourselves. My name is Adib Nur Hazim bin Mustafa. My matrix number is CE190169.
My name is Nur Hidayah Nazwa binti Sharidin, matrix number 8E190039.
Yes, my name is Hanif Hakim Ibn Azad and matric number is CE1900C3.
Hello, my name is Imran bin Muhammad Ghazali, matric number CE190118.
Okay. Firstly, we need to we start with mathematical calculation. Okay, this is the mathematical calculation. We find using a Fourier transform series. Okay, this is the that have been chosen. Okay, you can see here. It have two resistors, which is R1 100 ohm, R2 350 ohm, and we have one inductor 500 milliamps and one capacitor which is 1.0 microfarad. Okay, first we need to find and choose FT and VST. Okay, or V input. Okay, this is a FT. The formula of FT, which is AO plus sum of AN cos n omega t plus BN sin n omega t. And this is the waveform, the square wave waveform that we use. Okay, first we need to find, we can see here is a 1 and 0. So 1 and 0 for 1, t more than 0 and less than 1, and for 1 t is less than 1, more than 1 and less than 2. Okay, next. Okay, first we need to find AO. For AO we use this formula. Just simplify, and then we will get AO 1 over 2, and next we will find AN. Okay. And we will use this formula. Okay, we just simplify and we will get the answer 0. Okay, lastly we need to find BN. Okay, we use this formula and simplify using integrate, and we will get this answer. Okay, so this Vin that we use, which is BST, equal to 1 over 2 plus 2 over pi sum 1 over n sine n pi t. And for the n is equal to k minus 1. Okay, next. Next step, we need to convert time domain to frequency domain. Okay, this is the new circuit, which is the frequency domain. Okay, for the R is remains same, which is 100 ohm and 350 ohm. Okay, for the inductor, it become 0.5 S, and for the inductor 1 over S time the value of capacitor, which is 1 microfarad. Okay, this is a VST that we use. Okay, first step, we need to find AN and the angle of negative negative inverse of tangent time BN over AN. Okay, for AN, we substitute the value of AN and the BN. Okay, this is the value of AN is 0, and the value of BN is 2 over pi times 1 over n. So we will get the answer 2 over pi n. Okay, for the angle, we use the formula. Just substitute the value and we will get the answer negative 90 degree. Okay, this is the equation. Just substitute and we will get this equation. Okay, next. Okay, so we will find for n over 1, just for n over 1, just substitute the value 1 over in n and we will get the answer negative 90 degree. Okay, so this is the answer. Okay, for n over 3, okay, we will substitute the 3 and then we will get negative 90 degree, and this is the answer for P3 angle of 3. Okay, for n equal to 5, just substitute the value 5 and we will get the answer negative 90 degrees, still same, and we will get for the V5 angle of 5, we will get this answer. The next step, we need to calculate Z total. Okay, uh, we need to refer to the circuit, which is the circuit is the value of resistor will parallel with sum of inductor and capacitor. So just simplify using just simplify it, just substitute the answer, and then we will get this answer Z total. This is the answer of Z total. Okay, next, finding voltage output. I will pass to my friend Najwa.
Okay, so now we are going to find the voltage output. So that is the formula for voltage output, Z divided by ZT multiplied with VST. So we are going to substitute the Z with equation that we already find before and ZT. And then we will simplify this one and we get the equation for V naught. 175 micro S squared plus 350 divided by 0.035 S plus 225 micro S squared plus 450 multiplied with Vs. Okay, so now we're going to find voltage. By using the voltage equation that we already get before, we have to substitute the S with J and pi. So for N1, for the Vs, we insert 0.6367 negative 90 degree, and we get the answer 0.4952 negative 90.014 degree volt. So for N3, the Vs is 0.2122 negative 90 degree, and we get the answer 0.16505 negative 90.04 degree volt. So for N5, the Vs is 0.1273 with degree negative 90, and the answer is 0.0990 negative 90.07 degree volt. Okay, so we will rewrite the equation for V naught T, 0.4952 cos pi T minus 90 degree plus 0.16505 cos 3 pi T minus 60 degree plus 0.0900 cos 5 pi T minus 90 degree. Okay, now we are going to find current. The formula is I equal to V divided by Z and equal to V divided by R. So for N1, we insert the value V, 0.4952, negative 90.014, divide by 350. So we got the answer 1.4149 milli, negative 90.014 degree ampere. For N3, V is 0.16505, negative 90.04 degree divided by 350. So the answer for I3 is 471.57 micro, negative 90.04 degree ampere. So for N5, the V is 0.0990, negative 90.07 degree divided by 350. So the answer for I5 is 283.86 micro, negative 90.07 degree ampere. So this is the equation for I naught T, 1.4149 milli cos pi T minus 90.014 plus 471.57 micro cos 3 pi T minus 90.04 and plus 283.86 micro cos 5 pi t minus 90.07 degree ampere. Okay, so lastly, we will calculate for power absorbed by resistor, which is the power average. So that is the formula for power average. VDC is 1 over 2. IDC is 1 over 900. And then we will insert for V1 I1 divided by 2 cos the angle. And then V2 I2 divided by 2 cos the angle. And thus salah. Sorry. Okay, that is the formula for P average. VDC is 1 over 2, IDC is 1 over 900. Then V1 I1 divided by 2 cos angle plus V3 I3 divided by 2 cos angle and V5 I5 divided by 2 cos angle. So the answer is 0.95757 milliwatt. Then we rewrite all the equation again, so that's the answer.
Okay, next for the simulation, we use in P5. So this is the circuit simulation. That we insert the value from the calculation manual. So we have two resistors. For the resistor 1 is 100 ohm, and for the resistor 2, 350 ohm. So for the inductor, 500 millihenry, and for the capacitor, 1 microfarad. So when we run the simulation, next, okay, we get this waveform. The waveform for the before first Fourier transform. So next, okay, this one what you can see here. This one is waveform for the after first Fourier transform. So for the first waveform, for the compare with manual calculation. So for the manual calculation, we get 1.1419 micro. So this one for the waveform, we get 1.4 micro, something like that. So for the 3 pi, we get 471.57 micro. So from this waveform, we get 471.7 micro. So almost same, which are manual calculation. So for the 5 pi, we get manual calculation 283.86 micro. So for the waveform, for the result simulation, we get 284.0 macro. So almost same from the manual calculation. So that's all from the current net voltage.
Okay, this is the voltage from simulation before FFT, and we get 1 volt. And this is the voltage after FFT, and when we get the result 0.5 about 0.5 milli, 0.49 milli, and it is about the same with our calculation result. This is the power before FFT. We get about 2 watts. And this is the power after FFT. We get it about 0.0 0.8, but the result we got is 0.9.
Thank you.
Thank you.
Thank you.
Thank you.